Kamusta mo? Nakapasa na ba mo sa assignment? I mean, katong seatwork?
Ano, sir?
Sir, kanang ang po kumupasa, sir. Murag nawala
Mura,
lagi ang
oh,
pasahanan.
kuan man. Ako man siya kuan sa step good ka ng until 6 p.m. lang ba? Kuan na lang, i-email na lang sa ako Maghatag lang ko niya. Ay, karon na lang kay para ako i-chat direct ako email. Dire na lang ipasa.
Okay, sir. Thank you, sir.
Wala na ako nang i-chat. So, pwede na ka mag-email ron. Minsan yun is sige, so karon ato lang tiwason ning module 1 para makaproceed din ta sa bagong kuan na pod, topic na pod. So, ay wait, ang recording day. Sige. So let us continue. The topic for tonight is the relationship between magnetism and electrical current. Magnetism is a force of attraction between ferromagnetic metals such as iron, nickel, and cobalt, and a force of repulsion between diamagnetic materials such as antimony and bismuth. A magnet displays the properties of magnetism. So the figure on the lower right is an example of a magnet. So the magnet has two poles, namely north and south poles. A free-hanging magnet within the Earth's magnetic field will orient itself longitudinally between the Earth's poles. A strong link exists between electricity and magnetic field. The force of the magnetic field can produce electrical current flow in a conductor. On the other hand, electrical current flow in a conductor produces a magnetic field. So considering sa kaning figure 17.8, when a conductor is moved through a magnetic field, the force of the magnetic field generates a voltage in the conductor. This voltage causes current to flow through the conductor. When this happens, current flow is induced in the conductor. This phenomenon is called induction. Current flows in one direction when the conductor moves down the magnetic field. So, if the direction of the conductor, so kani siya ang conductor dere, so you move siya through this direction, the magnetic field is going downward. When the direction of the conductor moves up through the field, so meaning pa-reverse na pod, so the direction of the magnetic field also reverses. When stationary ang conductor nato, so pundo lang dere, there is no magnetic field produced. So wala siya. When a constant voltage is applied in a closed circuit, the voltage forces current to move in one direction through the conductor. As current flows in one direction, the magnetic fields of the electrons or charged particles align and combine to produce a strong magnetic field that extends around the conductor. Increasing voltage and thus increasing current flow produces a stronger magnetic field. Decreasing the voltage, thus decreasing current flow, reduces the magnetic field. So always remember, the voltage and current is directly proportional sa magnetic field. So kung mag-increase man gani ang voltage and current, increase po imong magnetic field. Otherwise, kung mugamay siya, mugamay po imong magnetic field. When the circuit is open, current flow through the conductor stops and the electrons again move in random paths. Their magnetic fields cancel. With no current flow, there is no magnetic field surrounding the conductor. Finally, if the connections of the conductor to the power source were switched, the polarity of the circuit would change. Current would flow in the opposite direction and the polarity of the magnetic field around the conductor would reverse. So, similar siya explanation sa katong figure sa last slide. So, next is direct current. Direct current is a current flow in one direction in an electrical circuit and it is always from the negative to the positive terminals of the power source. So, katong previous example nato sa circuits nato are examples of a direct current circuit. So, direct current circuit has DC voltage source such as batteries and solar panels. Kato sila, produce sila og DC electricity. And the direction of the electrons are moving only in one direction pag nag-on siya. So, constant ra ang iyang value. So, ra siya gingani. Pag naka-on ang imuhang DC circuit, so, ingani lang ang flow sa atong electrons. Next is the AC circuit or alternating current. So, alternating current is a continuous reversal of the direction of current flow such that at a point in time, the current flow in one direction is in one direction and at another point in time, it is in the reverse direction. So, consider ta sa figure na nasa lower left. So, kung mabantayan niyo, the pump ta og water, mo na yung water analogy I mean. So, naay times nga ang atong water nga gipump is going clockwise and napoy times nga going pud siya pa counterclockwise. So, considering the electrical circuit nga naa sa middle, so nga na po ang iyang movement in terms sa electrical connection. So, going right and at certain point in time, mo going left na po siya. So, considering also sa figure nga nasa lower right, it is the graph of the kanang mga rather waveform sa is kanang electricity. So, kanang red is direct current na siya. So, as mentioned, direct current, only one direction lang the move ang electron. So, meaning, atong voltage and current ana, pag naka-on ang system, is constant ang value nila in any point in time. Unlike sa AC, kung bantayan yung green nga graph, so sa AC is naa siya times nga come from 0, niadto siya sa positive maximum voltage or current. Then, balik na po siya 0. So, kana siya nga kuan, cycle is 1/2 cycle na siya. And, gikan sa 0 na po, ato na po siya sa negative maximum voltage niya. So, balik na po din siya sa 0. So, this change from one direction to the next and back is called a cycle. So, ang cycle guys, sa isa ka AC waveform is coming from this point, sa starting point niya nga 0 to the 0 after makamake kag cycle on the positive and negative cycle sa imahang waveform. So, isa ni siya ka-cycle kani. So, the unit of So the frequency is the term that describes the cycles per second and it is expressed in hertz. So kung moingon tang 60 hertz ang ato ang frequency, so ang cycles aning waveform is 60 times 60 ka cycles in 1 second. So paspas ra kaayo siya. Kung hinay pa lang ni ang atong cycle guys, makabati ta nga ang atong mga suga mag-blink-blink siya kung hinay ang atong cycle. Kung 60 hertz ang atong second, di man nato siya ma-feel kipaspas mong kaayo. Okay? Excuse guys, ha, kadali lang.
Okay na, sir.
Sige,
Tingala sa
sorry kay
next
guys.
ang slide, sir.
So, pabalik lang ko ha. So, ang waveform is a representation of how AC varies with time. So, the common AC waveform is sine wave, which is derived its name for the reason that the current or voltage varies with the sign of the elapsed time. Other types of AC waveforms may be produced by certain types of electronic oscillators, uninterruptible power supplies operating from a battery, and some audio amplifier. So, sa UPS guys, ang naka-produce niya nga waveform is nasa square wave, while ang oscillators na to is pwede siya square, triangular, or even sine wave. So next is the voltage produced by an AC power source is specified by its average voltage. For example, on the 120 volts single phase AC system, the voltage reaches about a maximum of 170 volts but averages 120 volts. So referring sa figure nga nasa ubos, the area below the sine wave determines the average voltage. So the maximum voltage on a 120 volts AC circuit is 169.71. So, yun sana siya pagkuha. So, 120 times the square root of 2. Kaning 169.71 volts is called the peak voltage or the maximum voltage of the system. So, sa pagkuha ng peak voltage. So, peak voltage is equal to average voltage times square root of 2. Nakuha ba to?
Yes, sir.
Okay, so what if lugar guys kung ang average voltage sa system na to is naa sa 230, pila lugar iyahang peak voltage? Anyone? Yes, Kirby.
325.27, sir.
Okay, correct.
Thank you, sir.
Sige, so I think nakuha na siguro. So, proceed ko. So, for generating electricity, an electric generator is used. So, unsa man ni siyang electric generator? So, it is a mechanical device that converts mechanical energy into electrical energy. An armature, a shaft with conductor windings or coils wrapped around an iron core, is rotated through a stationary magnetic field. Movement of the conductor windings through the field produces current flow. An AC generator produces alternating current that keeps reversing its direction of flow. So, ga-refer siya diri sa figure 17.13. When the conductor windings move through the magnetic field between the poles of the stationary magnet, current is induced in the windings. During one half, one mong ko. During one half of the rotation of the armature, current is pushed in one direction. During this half rotation, voltage changes from 0 to maximum voltage, then back to 0. So, referring to the figure, atong conductor is this one. So, pag mo rotate na ang atong generator, ang iyahang kuan ana, yung pulse ana, yung magnetic field is ga kuan pod. So, ingani po siya may tabo sa electrical. So, gikan sa 0, mahimo siya positive volt kuan, positive maximum voltage, then balik og 0. So, siya, ang A nga portion is nag-atubang sa south, ang B na sa north pole. Pagkabalik na po ng 0, so 0 na sad ni siya. Kay considering nga ang atong kaning A ug B is facing perpendicular sa north and south pole. Tapos from C kani siya, so unsa man ni siya be? During the second half of the rotation, voltage pushes current in the opposite direction because the windings are moving through the magnetic field in the opposite direction. So, ni-rotate na po ni atong conductor na napod siya sa North Pole na po nakatubang. So, nabali na po siya. So, that's why ang atong electrical voltage niya is nasa negative maximum voltage. Then after na, balik na po siya zero diode. This alternating change in voltage and thus current direction is why the system is called alternating current. Most power generated in the United States and Canada is produced with the generator armature rotating 60 times a second. Therefore, 60 times every second current flow is in one direction, 60 times every second it is in the other direction, and 120 times every second there is no current flow. So referring also sa figure na nasa ubos, so this is an example of a coal power plant. So dere na to makita ang electric generator nga nagproduce og electricity. So gikan sa coal, gibutang siya dere sa burner. So gisunog ang coal, then ginaboil ang water. The water in turn will produce that steam. So kaning steam is causes the turbine nga gikouple sa generator to rotate. So kaning turbine nga nag-rotate exhibits a mechanical energy. So nakakouple man siya sa generator, so ang generator po dato is mag-rotate po siya, which in turn mag-produce og electrical energy nga output. Kanang electrical energy nga output niya is maunay iyang i-transmit padong sa transmission lines, then going to distribution, and lastly, padong sa consumers. Nasabtan ba to?
Yes, sir.
Yes, sir.
Wait lang. So next is the single-phase alternating current power. A single-phase alternating current distribution system refers to a system in which all of the voltages of the supply vary in unison. A basic system typically has two conductors. One is neutral and the other carries current, or also known as the live conductor. So, sa ato sa Philippines, it's one ground, then one line. I mean, one live. In Cagayan de Oro, sa ato adere, ang connections na to is line to line ta. So, duha ka live wire na siya. In some cases, like in North America, ang ilang gamit dito is 3-wire single-phase distribution system. Commonly used siya in residential and light commercial buildings nga up to 100 kVA nga applications. So, ang purpose sa kanang 3-wire single-phase is pwede na siya makakonect into duha ka separate nga single-phase nga system, considering na kay duha ka live conductor and one neutral. As seen in the figure below, ang need na to nga wires is line and neutral. So, parallel ra na sila hangtod sa ma-connect ng mga loads na to. So, mayroon tag loads kani mga appliances na to. So, daring sa left side is the supply na to sa coming from the grid. So, i-distribute din siya padong sa inyohang mga appliances dayon. So, nga na siya. Single-phase power system requires fewer wires on both the electrical distribution system and the customer system, which results in lower installed costs. It is most often used in homes, small businesses, and farms. Next is the three-phase alternating current power. The three-phase alternating current distribution system consists of 3 separate lines of single-phase power, with each line out of phase by 120 degrees or 1/3 of a cycle. The voltage peak of the first phase leads the voltage peak of the second phase by 1/3 cycle, and the voltage peak of the second phase leads the voltage peak of the third phase by 1/3 cycle, and so on. So, referring to the figure below, ang three-phase connection has 3 live conductors, one neutral and one ground conductor. So, dere sa Philippines, sa commercial establishments, there is 3 live wires and 1 ground wire. So karon guys, ang three-phase nga so karon mo tanak ko, how many single-phase connection can be made from a three-phase connection? Anyone? Again ha, how many? Oh, yes, Jason.
3, sir.
Okay, thank you. So, 3 ang atong mabuhat ana since again, ang single phase only needs one live conductor and one neutral conductor. So, referring also sa figure, so makita ninyo ang R nga linya is na siya one single phase connection. Then, nakakouple sa neutral. The next is the Y, then neutral na pod, so another single phase. The next is the blue, connected and neutral na sad. So another single phase connection na po na siya. So mo nang 3 ang atong mabuhat ana. Yes, Kirby.
Sir, ano yung meaning ka ng E dira, sir?
Wala siya. Earth na siya. Earth or ground na siya, Kirby.
Okay, sir. Thank you, sir.
Oh, yes, Joby.
Sir, may I know, like, unsay purpose sa neutral, sir?
Sa neutral, dira agi ang excess nga current sa system. Typically, sa three-phase nga system, ang summation sa voltage sa kada phase is equal to 0. Karon, if times nga naay excess current ana, sa neutral na siya mapadulong.
Okay, sir. Kanang ano na excess, sir?
Sa faults na siya, naay problema sa system ba?
Okay, sir. Sige, thank you, sir.
Sige, so next. Transforming voltage and current. In an AC circuit, the strength of the voltage and polarity of the power source are always alternating. So rate and direction of current flow are always changing. As current flow increases in the circuit, the magnetic field surrounding the conductor increases. And as current flow decreases, the field decreases. Fluctuation in rate of current flow causes the magnetic field surrounding the energized conductor to expand and collapse. If a secondary stationary conductor is positioned within this collapsing and expanding magnetic field, the force of the field induces a voltage across the second conductor. This voltage drives current flow in the second conductor, but the second conductor does not have to connect or touch the energized conductor, nor does it have to move. Instead, the expanding and collapsing magnetic field of the energized conductor induces a voltage in the second conductor. So, natay device to transform the voltage and current. So, when we say transform, we either step up or increase ang voltage or step down the volt or step down or decrease the voltage. So, transformers serve as an efficient way of converting power at a primary voltage and amperage to the equivalent power at a different secondary voltage or amperage. In simple transformer composed of two coils, the ratio of the alternating current output and current output voltage to the AC input voltage is approximately equal to the ratio of the number of turns in the secondary coil to the number of turns in the primary coil. So, before itong proceed, kung bantayan ninyo, familiar ba mo na sa transformer ninyo sa gawas, no? Kana makabantay mo muna sa poste.
Yes, sir.
Yes, sir.
So kanang transformer na to, ang iyang itsuraan na is similar ani nasa ubos. So kani siya is single phase ni siya, then naa siya single core ani. So karon considering na kay grade supply, so diha siya sa primary side mo sulod or sa primary supply. Karon when current and voltage is flowing through the primary side, so mag-produce siya og magnetic field. So this magnetic field induces voltage on the secondary side. So ang voltage nga na-produce dere produces current which in turn maoy ginagamit pang supply sa balay. So ang value ani nga voltage is gamay na ni siya because i-step down siya because sa transformer. Kaya kung dili na to na i-step down, mga daot ang atong mga appliances ana. Example, if ang utility nag-provide og voltage sa primary side of 13.8 kilovolts, so ang ato ang voltage sa secondary side is 230 volts na siya. So, step down siya ayo. Pero ga-produce gyapon og the same amount of power. Nako ba to nato?
Yes, sir.
Nakuha ra.
So always remember lang the power coming from the primary side is equal to the power on the secondary side without consideration sa efficiency. So isa na ninyo ka way of checking nga sakto ang inyuhang gipang solve pod nga values. So the equation for the transformer is primary voltage kaning EP over number of turns sa primary side NP is equal to voltage sa secondary side over number of turns sa windings in secondary side. So proceed tag example para masabtan nato ni siya. So example 5, a 225 kVA transformer located outside a building is used to step down the voltage for the building. It is connected to a 7,200 volt AC power source. The ratio of the number of primary windings to the number of secondary windings on the transformer is 30 to 1. So first, approximate the voltage provided to the building. So based sa atong example 5 guys, unsay given na to ani nga problem di ay? Anyone? Again ha, based on sa example number 5, unsay given sa problem? Christian Clint,
225 kilovolts ang reason.
sa pa?
7,200 volts sa AC power source.
Unsa man na siya? Asa man na siya nga side? Sa primary ba na or secondary?
Primary, sir.
Okay, unsa pay lain?
Then 30 to 1 ratio sa secondary.
Okay, sige. Thank you sa answer, Christian Clint. So since given man ta primary voltage and transformer ratio, so based sa formula, ang wala nato is ang secondary voltage, which is mao atong gipangita. So kuan na siya, arrange lang ang formula. So substitute lang nato ang values diretso. So natay 7,200 times 1 over 30. So ang voltage provided to the building is 240 volts. Nakuha ba nato?
Yes, sir.
Yes, sir.
Para, sir.
So next, part B. Approximate the current available in the building in amps. So karon, ang gipangita na pod is ang current na pod sa secondary side. So given man ta og power sa transformer of 225 kVA or 225,000 kVA. So, kaning VA is the unit of AC power. Pero, dili ni siya actually equal sa watts. Kuan pa siya, napa siya lahi nga component nga kailangan para ma-express nimo siya in watts, which is later matakol lang nato siya. So for now, let us consider nga ang wattage of VA is equal. So karon review lang, what is the power formula given voltage and current? Again
What was the
guys,
question, sir?
unsay formula sa power given voltage and current?
Multiply lang ang duwa, sir.
German.
Kuan sir ka na voltage times current.
Okay, thank you. So, ang power is equal to voltage times current. So, since current hindi pangita, so atong i-bylaw ang power o ang current. So, the current is equal to power over voltage. So, 225,000 divided 240. So, na kay 937.50 amps. Nakuha na ba ni?
Yes, sir.
Yes,
Nakuha.
sir. Yes, sir.
So, karon guys, to the transformer, given na 7,200 volts ang imong primary voltage using the same transformer rating. Again, guys, what is the primary current provided to the transformer if the voltage is 7,200 volts and the power is 225 kVA? Jason.
31.25 ampere.
Okay, so Jason, okay. Sige, ayun na lang. Salamat sa answer, Jason. So, I guess nasabta na siguro. So, proceed na ta. Yes, Christian Flint. Christian Flint?
Never mind, sir. Wala. Sorry, sir.
So, next example. A 150 kVA transformer is used to step down the voltage coming from Sepalco. If the voltage coming from Sepalco is 13.8 kilovolts and the number of turns for the primary winding and secondary winding is 1,169 respectively. Determine the secondary voltage used to supply the building. So, pasolve na guys. So again a 150 kVA transformer is used to step down the voltage coming from Sepalco. If the voltage coming from Sepalco is 13.8 kilovolts and the number of turns for the primary winding and secondary winding is 1,169 respectively. Determine the secondary voltage used to supply the building. So, kinsay makasolve na? Jason pagyapon. Christian Tint, yapon. Kirby, yapon. Sila ron to nag-solve? Naya Lendi. Nakadira, Lendi.
Na, sir.
Unsay imong answer sa secondary voltage ani? Example 6.
220, sir.
Yun siya nimo siya.
Sir, primary voltage times secondary winding divide primary winding, sir.
Unsa na imong primary winding?
Sir?
Unsa na imong primary winding?
1,100, sir.
Yan ang secondary.
69, sir.
Pero unfortunately, di man siya makuha nga kana. So, lahi ang formula. Ikaw daw, Prince, sa imo.
Pwede mo try lang, sir. Di pa ko sure.
Sige daw.
Dili siya 865 volts.
Yep, kana siya.
Kana.
Oo, yun sa po ni mo mga Prince.
Ay, kuan lang, sir. Kanang nag-shift solve ako sa calculus bitaw, sir. Niyang pangita ba na ako missing ang secondary.
Pero sa imong formula, nag-i-input.
So, kuan nga lang, kadito lang siya. So, 13.8 volts times ang secondary nga winding, which is 69, divided by condenser, 1,100.
So imong gi-multiply ang 13.8 og 69 then divide 1,100.
Yes, sir.
Okay. Okay, sakto na siya, mapaagi. So kato kang kuan, isa tong tawagan ako kanina si Lendi to, no? So mura na bali ang imo ka Lendi. So mo tong na 230 to siya.
Okay, sir.
Kaya at least awareness lang po. So, ang uban nakakuha ba sa 865?
Yes, sir.
Si Joby rin nakakuha na eh. Kung aside atong
Yes, sir.
nagtataan.
Yes, sir.
Yes, sir.
One,
Nakuha
sir.
na sir.
Okay, sige. So next, alternating current is used exclusively in the United States in residential and commercial wiring because it provides greater flexibility in voltage selection and simplicity of equipment design. The principal reason is that when AC is used, the voltage can be increased or step up or decrease or step down very easily and efficiently through the use of transformers. A transformer is about 95% efficient in making the conversion. By comparison, an electrical DC generator, the only means of changing DC voltage, is about 75% efficient. Aside sa electrical generator, naapod tayo natawag na DC to DC converter. But same, diili kayo siya yung ka-efficient. So, a DC to DC converter can be used to increase the DC voltage or decrease the DC voltage. So next topic is the impedance and power factor. So before the discussion of impedance, we will first discuss the inductors and capacitors. An inductor is a coil of wire that creates an electromagnetic field. On AC circuits, inductive loops are created as current flows through coils or windings found in motors, transformers, and light fixture ballast. The inductive effect on a series AC circuit causes the phase of the voltage, current to lag behind the phase of the voltage. That is, peak amperage lags peak voltage. So the figure below are examples of inductors. So next is the capacitor. So capacitor is composed of metal plates separated by air or dielectric materials such as paper, ceramic, or mica. Capacitors store electrical energy in an electrostatic field and release it later, much like your body stores and releases static electricity. You rub your feet across the carpet and touch a grounded object. The capacitive effect on a series AC circuit causes the phase of the current to lead the phase of the voltage. That is, peak voltage lags peak current. Although there are no inductive and capacitive effects on DC circuit, current flow on an AC circuit is impeded by inductance and capacitance. So the impedance is a measure of resistance to current flow on an AC circuit due to the combined effect of resistance, inductance, and capacitance. And it is measured in ohms. So impedance, ang unit niya is similar sa resistance. Sila. So again, na ko, review. What is the formula for Ohm's law when voltage is asked? Again, unsay formula sa voltage ko ang in Ohm's law? Anyone? Janil Rose?
Voltage is equal to current times resistance.
Okay, thank you. So, voltage is current times resistance. So, karon sa AC, ang voltage is equal to current times impedance. Similar rin siya sa Ohm's law sa DC circuit. So, E is the voltage, I is current, and C is impedance. So, example, the impedance values of incandescent lamps with 3 wattage ratings are noted below. With a voltage of 120 volts on an AC circuit, determine the current of each lamp. So again, in Ohm's law, current is equal to voltage over impedance. So first, natay 100 watts nga lamp. So ang kanang 100 watts nga lamp has 121 ohms of impedance. So given naman ang voltage nato, yes, Maria Christine. Maria Christine Asibar. Wala lagi to siya. Okay, so proceed lang sa ko. Kaya man siya yung istorya. So, ang current sa 100 watts nga lamp is equal to 120 over 121 ohms. So, equal sa 0.992 amps. For the 75 watts nga lamp, natay 161 ohms of impedance. So, the current is equal to 120 volts divided by 161 ohms, which is mo equivalent siya to 0.745 amps. And lastly, for the 40 watts nga lamp, na kay 300 ohms nga impedance. So, the current is equal to 120 volts divided by 300 ohms or equivalent sa 0.4 amps. DC and AC circuits form differently with respect to power use. On a DC circuit, the product is measured in voltage and the product of measured voltage and measured amperage equals wattage. So P is equal to voltage times current or P is equal to E times I. On most AC circuits, the computed volt amperage is different than power consumed. That is, the product of the measured voltage and amperage does not equal to wattage. This phenomenon is related to the inductive effects in circuits powering motors, transformers, and magnetic ballast as described earlier in inductors section. So there are 4 components sa atong AC power. So, para ma-picture out na to siya, consider this glass of beer. So, naatay first, real power. So, real power is the usable power. Kung in terms sa beer, siya ang liquid na part sa beer kung asa mainom na to na siya. So, sa rin real power in terms of electricity. So, real power is the working power that performs useful effort in a circuit, such as creating heat, light, and motion, and expressed in the units of watts or kilowatts. It is that portion of the power flow average over a complete cycle of the AC waveform that results in a net transfer of energy in one direction. In a circuit, a wattmeter reads real power. The utility company charges its customers based on real power. So, aside sa real power, dapat tayo ginatawag nga reactive power. In the case of beer, siya ang kanang mga bula dira, which is wala tayo mainom nga liquid dira sa beer. Bula lagi na siya. So, in electricity, it is the wasted electricity. It is also the power that generates the magnetic field required for inductive devices to operate. It dissipates no energy in the load, but which returns to the source on each alternating current cycle. It is expressed in volt amps reactive or kilovolt ampere reactive. Reactive power required by inductive loads increases the amount of apparent power in a distribution system. So, third is the kVA or apparent power. So, the apparent power kung there is a beer is the whole glass of beer nga naay sulod nga katong liquid o katong bula. So, kaning kVA or apparent power is the total energy available to use or powered eh. It is expressed in volt amperes or kilovolt ampere. Pantimanan ninyong unit ha, kay lahi na ba ang units yun. Because it is simply the product of voltage and current. Apparent power is the total power required by an inductive device that is a composite vector sum of the real power and reactive power. It can be computed as the product of measurements made with voltmeter and ammeter in a circuit. So guys, ang actual nga solution for the apparent power consists of real numbers and imaginary numbers. So kung magamit ta sa complex form sa inyong calculator sa mga 991 nga model, naaman tayo complex form dira para maka-solve ta sa complex form of apparent power or vector sum niya. So, dire sa ato is dili kay ta magtakol anang mga complex forms of. Okay, so proceed lang ko. Next is the power factor. The power factor for a single phase circuit is the ratio between real power and apparent power in a circuit. So, power factor is equal to real power divided by apparent power or P over S. So, ang P is the real power and S is the apparent power. The power factor is a number between 0 and 1. It is often expressed in percentage. In a single-phase circuit or balanced three-phase system, the power factor can be measured with the wattmeter, ammeter, voltmeter method where the measured power in watts is divided by the product of measured voltage and current. Equipment specifications provided by the manufacturer and motor nameplates often designate the power factor. Where the AC waveform is purely sinusoidal, true power and apparent power can be thought of as forming the adjacent and hypotenuse sides of a right triangle. So the power factor ratio is also equal to the cosine of the phase angle. For this reason, equipment nameplates and manufacturer information will frequently abbreviate the power factor as cosine phi. So considering nga natay right triangle there is a right side, so always remember nga ang power factor nato natay power factor dire. So ang iyang adjacent side is the real power and the reactive power is on the opposite side. And ang iyang hypotenuse is the apparent power. Apparent power can also be solved by using the Pythagorean theorem. So, nga ni siya ng example. So, makita rin nato ni sa following example. So far, nasabtan ba ni nato ng triangle o kaning power factor?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So, next example, number 8. A circuit consumes 3,000 watts of real power when the apparent power is 3,600 volt ampere. So, first, determine the power factor. So, unsa may given di ay sa problem para ma-determine na to ang power factor? Anyone? Yes, Tadlas. Pilay value anang real o apparent di ay? Okay, so since given ang real power and apparent power, thank you sa imong answer, Bella. So, i-divide lang nato ang real power sa apparent power. So, 3,000 divided by 3,600. So, naka-power factor of 83%. Next is determine the phase angle phi. Remember, ang power factor formula na to is also equivalent to cosine phi. So, gikuha lang ang cosine inverse para sa makuha na to ang value ni phi. So, ang given na power factor, ang phase angle is nasa 33.6 degrees. Nakuha na ba ni na to nga example?
Yes, sir. Nakapar.
Yes, sir.
So, proceed to. So, sa example 9, a building consumes 4,000 watts of power and reactive power of 3,000 var. Determine the apparent power and power factor consumed by the building. So guys, ako ipasolve una ang apparent power sa inyo ha. So please ko solve ana. Yes, Juby.
Di ko sure, sir. Tama ba ang answer kay 5,000 po for the apparent power?
Unsay unit anang 5,000?
5,000 kVA.
Ay, dako na kaayo.
Ay, 5,000 VA. Sorry po. Wala K.
Ah,
5,000.
Okay, thank you sa answer, Joby. So, the apparent power is 5,000 VA. Nakakuha ba ang uban, ana?
Yes, sir.
Ang uban, si Jason rin nakakuha? Or anyways. So, next, palihog kong solve sa power factor. Ikaw daw, Jason.
0.80 or 80%, sir.
Okay, thank you. So, ang apparent power, again, is 5,000 volt ampere or VA. And ang power factor is 80%. So, ang uban ba, nakakuha ba na ng mga answers?
Yes, sir.
Okay. So again, pag after sa manipulation sa iyang equation, so ang power karon is equivalent to apparent power times power factor. In example 8, the power factor is less than 1, which means that the apparent power and real power are not equal. When an AC circuit is purely resistive, it draws current exactly synchronized and proportional to voltage. That is, voltage and current peaks occur simultaneously. As a result, the apparent power and real power are equal, and the power factor is 1. If the circuit in the previous example had been purely resistive, a full 3,600 watts would be delivered to the load rather than the 3,000 watts. A poor power factor makes an inefficient delivery of power. On an AC circuit, voltage, current, and power factor are applied to determine your power through the AC power equation. So again, ang apparent power is voltage times current. And real power is equal to voltage times current times power factor. In buildings, circuits are hardly ever purely resistive, so the PF is generally less than 1. In residential units, the typical PF nara sa mga 0.9999. Clients serving inductive loads tend to draw current with a phase shift. That is, voltage and current peaks occur out of sync. This phase shift causes voltage to sometimes be positive when current is negative, or current to be positive when voltage is negative. In instance where power is negative, a motor is actually behaving like a generator feeding power back into the system. As a result, it takes more current to deliver a fixed amount of power when current is shifted out of phase with the voltage. Real power and apparent power are not equal. Inductive circuits have a power factor of less than 1 as the amount of mo- as the amount of inductive load is a circuit increases, the PF decreases. The main contributor to a low PF is motor operated at less than full load. The power factor measures how effectively the power delivered powers is being used. A running a, mo- a motor running with a zero point 0.7 power factor indicates that only 70% of the current provided by the electrical utility is being used to produce useful work. In contrast, a motor running with a 0.85 PF will use 85% of the power. A higher PF at the motor means more of the supplied energy will be transferred into usable work by the electrical system. In contrast, a low PF means the current flowing through electrical system components is higher than necessary to do the required work, which is an inefficient use of power. A low PF is caused by electrical circuit having greater amount of inductive loads such as conveyors, compressors, grinders, HVAC systems, machining equipment, and welders, and etc. Industrial and commercial electric customers operate the operate with system PFs between 0.75 and 0.98. A PF for a building system below about 0.95 is considered low. The PF is an important consideration in design of an AC circuit or system because when PF is less than 1, the circuit's wiring has to carry more current than would be necessary to deliver the same amount of real power. Power companies supply customers with apparent power, measured in volt amperes, but charge them for real powers, expressed in watts consumed. So, from the perspective of the power company, a low overall PF means the power company must provide more generating capacity than actually is required. The goal of a power company is a PF of 1 or unity power factor. As a result, power companies require their customers, especially those with large loads, to maintain their PFs above a specified amount, usually 90%, 95%, or even higher. Power companies measure reactive power by use of high, I mean, the power companies measure reactive power used by high demand customers and charge higher rates accordingly. So, in order to increase the power factor na to, we apply power factor correction. Commercial or industrial operations rarely achieve a power factor of 1 because inductive loads from motors, transformers, and light fixture balas are common. This inductive effect causes the phase of the current to lag behind the phase of the current. A greater lag in current results in poorer power factor. The PF can be improved by adding capacitance to the circuit. A capacitor has the effect of causing the phase of the voltage to lag the phase of the current, and thus reducing the lagging effect caused by inductive loads. Capacitors or synchronous motors are frequently used to counter the effect of inductive motors and transformers in industrial applications. Some consumers install power factor correction devices such as capacitor to cut down on higher costs associated with low power factor. For example, modern fluorescent fixtures have a PF correction device that improves PF to 0.90. A power factor in an AC circuit can be corrected by adding a parallel reactance opposite the effect of the load's reactance. Most commonly, the load's reactance is inductive in nature, so a parallel capacitance can be added to correct the low PF. For example, industrial plants tend to have a lagging PF where the current lags the voltage. This is primarily the result of having several electric induction motors in operation. Some industrial sites will have large banks of capacitors called power factor correction capacitors, specifically for the purpose of correcting the power factor back toward 1 to save on your power company charges. Power factor correction capacitors are not perfect. They only provide a PF close to 1 when the power supply is it at near its full rated load. So there are three advantages of power factor correction. So first, a high power factor reduces the load currents, resulting in a considerable saving in hardware cost such as mga conductors, breakers, switchgears, substation transformers, and so on. Next, power companies typically impose low power factor penalties. So by correcting the power factor, the penalty can be avoided. And lastly, the electrical load of the power company is reduced, which allows the power company to supply the surplus power to the other consumers without increasing its generation capacity. So kani siya diri guys is the summary lang sa formula sa ato ang DC power, AC power, then even current and power factor. So sa DC power guys, ang atong power is equal to voltage times current. For AC nga circuit, ang in a single phase circuit, ang atong AC real power is equal to voltage times current times power factor. In a three-phase circuit, nadugang na to ang 1.73. nga constant factor or it is equal to square root of 3 kanang 1.73. So next is AC apparent power. So wala may apparent power sa term sa DC. Sa manak mo ni. So moto, ang apparent power is equal to voltage times current lang siya. Kung 3-phase ang imong system, na kay square root of 3 times voltage times current. So tanang formulas ni 3-phase is na ay 1.73 or square root of 3 sa formula niya. Nakuha ba ito na to?
Yes, sir.
Yes, sir.
Yes, sir.
So next is the cost of electrical energy and power. The utility company will charge its customers for the electrical energy consumed, and for all but small users, such as most residential customers, the rate at which energy is consumed. The charges make up the largest part of a typical electric bill. So first is the energy charge, next power demand charge, third is demand limiting and load shedding, next is time of use rates, and lastly, additional charges. So here is example of electric bill. So before lang ana, proceed na sa taani, balik na sa bill. So first nga component sa cost sa electrical energy is the energy charge. Energy charge is simply the cost of electricity or electrical energy consumed. This may be computed by the following equation where the energy consumption Q is expressed in kilowatt hours and the unit cost of electricity in dollars per kilowatt hour. So again, review lang, unsay unit sa energy gani? Perihan, Vincent,
Joel, sir.
a unit man ang pautan na, no?
Oh, yes, sir.
Sige, thank you. Joel, okay, isa na siya ka-unit.
Yes, sir.
Sige, sige. Salamat sa answer, Vincent. So, ang question na kinako originally, unsay formula sa energy? What is the formula of energy? Joey,
Power times time, sir.
okay. So, unsa may unit anang power nimo?
Watts, sir.
Okay. Sige, thank you. So that energy charge is equal to energy consumption times unit cost of electricity. So the energy charge is based on energy consumed by the customer during a billing period, say 1 month or every 30 days. Energy consumed is determined by reading the electric meter. So sa kaniya case, balik ta sa katong sample nga electric bill. So dere siya na-apply tong energy charge kaning kilowatt hour consumption. So kabantay ba mo anang meter reader nga mag-anha sa inyong balay?
Yes, sir.
Yes, sir.
And nakabantay ba mo anang sa meter ninyo kanang mga naidako nga numbers? I think 4 or 5 na sila ka digits.
Opo,
Yes,
sir.
sir.
Yes, sir.
Okay. So katong dagko nga digits nga mo na basahon ni meter reader. So let's say ang meter reader ani nga residential billing is nagbasa siya at on February 17, 2022. So ang nabasa niya is naa sa 9,790. And last month sa January 18, Ang iyang basa di ay is 9,712. So kanang period covered nga January 18 to February 17 is the billing period. So karon para makuha na to ang energy consumption, so let us subtract present to previous value. So mo nang naa kay 78 kilowatt hour consumption. In terms sa commercial na mga buildings and industrial setting, ang kuha nato, ang energy consumption nato is present minus previous, then i-multiply sa multiplier. Because ang multiplier sa mga industrial o commercial is na dagko nga values. Let's say na siya 40, 80, 100, 150, and so on. So depende na siya actually sa current transformer nga gi-attach sa system. So kung mabantayan sa ninyo, ang sa kwan atong bill, ang charges nga naa is the generation and transmission revenues. Next, the distribution revenues. Third is subsidies. Next is government taxes. And lastly, universal charges. Nasabtan ba to ninyo tong kaganina guys? Kato itong magbasa na og energy consumption in a month? Joby?
Ngano lagi na yung multiplier, sir?
Kuha na siya, tungod na siya sa mga current transformer nga gi-install sa system sa client.
Okay,
So,
sir. Thank you.
Nasabtan na ba na to ang process kung ginaunsa ni meter reader ang pagbasa sa atong consumption?
Yes, sir.
Yes, sir.
Yes, Jesus.
Yes, sir. Yes, sir.
Sabi na kong nautan na. Sige, so proceed to example. Example number 10, a 60 watts lamp remains lighted for 24 hours a day for 30 days. Determine the electrical energy consumed over this period. Calculate the energy charge for the billing period at a rate of 0.1172 dollars per kilowatt hours. So karon unsay given aning example number 10? Anyone?
Time. Ay,
Yes, Shane.
time,
Sige na,
sir. Day og power, sir.
masabi mga values na nila.
Sa time is 24 hours, then sa days is 30 days, and sa power is 60 watts po.
Kana lang tulo.
O ang ano po, rate sir na 0.1172 kilowatt hour.
Kana siya, dollars per kilowatt hour na siya.
Ay, dollars. Ay, sir, sorry, sir. Wala na ko.
Unit cost ang tawag na.
Sorry po.
Unit cost of electricity ang tawag ana nga charge ha. So, ang require ani is ang energy charge. So, karon to solve the energy, the formula is power times time. Since gi-mention nga ang light is ipasiga for 24 hours a day, then kao na to ang energy consumption for 30 days. So, mo lang, ang formula na to is 60 watts times 24 hours per day. Then, i-multiply pa yun og 30 para makuha ang isa ka billing period na energy consumption, which is naa siya sa 43.2 kilowatt hours. So, ang gamiton nato sa sunod is ang kilowatt hour per billing period, dili ang watt hours. So, pag abot sa energy charge, Q times unit cost of electricity. So, substitute lang nato. So, 43.2 kilowatt hours times 0.1172 per kilowatt hours. So, ang imong total na energy charge is $5.06 per billing period. Nasabtan ba nato ni?
Yes, sir. Kanang naki question, sir.
Hmm. Yes,
Katong
Juby.
sa assignment ba, sir? Katong last bitaw. Di ba na ay question na pangitaon ang energy, di ba, sir? Katong power times time. Kanang kailangan i-kilowatt hour to, sir?
Asa na ka number imong gi-refer?
I forgot. Pero naato siya murag energy bitaw, sir, na question, sir. Kailangan dito siya i-kilowatt hour, sir?
I think number 3 to
Oh, kilowatt hours to.
What if wala na convert, sir? Okay na to, sir.
Okay naman, pwede naman po ta mag-watt hours as long as wala ta nag-solve sa energy charge. Pero kung mag-solve na ta sa energy charge na to, kung mag-solve na ta sa tong energy charge, diha na ta mag kilowatt hours ang gamiton because ang charge ni utility company is naka kilowatt hours man based man sa kilowatt hour consumption nato dili watt hour na consumption.
Okay, sir.
Actually, number 3 nga assignment. Ito na po ba? Wait lang guys ha. Kung sakto ba akong pagsabot sa gi-refer ni Joby. Wala po man tamo gitagag assignment pero ano na mo kabalo na po about sa assignment. Nakita ninyo sa USTEP?
Ay,
Cheat work ata, sir.
Katong homework to, sir. Katong last time bitaw.
Seat work?
Katong seat work 1, oh.
Wala pa man tayo
Sir,
energy
seat
work.
Naghatag na kasama, sir.
Katong drawing sa series of parallel, sir ba?
Ah, kana ka. Ay,
1 to
okay ra
6,
na
sir.
what
1 to
hours?
6.
Oy. Okay ra na what hours? Wala tay problema dira. Okay ra ta sa what hours. Abi na ko katong kuan na assignment.
Thank you, sir.
Ay, so natin assignment na yun, sir.
Oh, unya. Natay assignment akong ihatag unya. Eh, nalibog sad ta kadali da. So kaning sa number 3 nga gi-type ni Jason is pwede ra ni what hours lang answer ani. Kay wala man ta nag-solve og cost sa atong energy consumption. Kung magkuha na ta, kung maabot na ta sa mag-calculate og energy charge, diyan na ta mag kilowatt hours ang gamiton na to. Okay? So proceed ko sa next nga example. Ay, before di ko proceed, nasabtan ba ni ninyo?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Maghatag lang example. Okay, wait lang. Medyo na libog kagamay lovely. Asa nga part? Okay guys, so what if naatay given nga power of 90 watts then gipasiga siya for 12 hours a day and ang billing period nato is 29 days. Considering nga natay unit cost of electricity of $0.1172 per kilowatt hour, pilay energy charge nato. Ako gi-chat pud ang given nato guys ha. Sa palihog daw kog solve. Kami. Ikaw daw, Shane.
31,320 watt hours, sir, per billing period.
Pila to imong kuan? Imong kilowatt hour per billing period?
Ano, sir? 31,320.
Watt hours lang na siya or kilowatt hours na siya?
Wait lang. Watt hours, sir.
Okay, watt
I
hours.
know, sir. Ano di ay, sir? 31.3 kilowatt hour per billing period.
Okay, so unsa man pod ang energy charge nato? So, kinsa man akong tuwagon karon be? Prince Edward, pilay energy charge nato?
3.67, sir.
Okay, good. Kuha ra. So I guess nakasabot ang majority. Nakuha ba nato tong mga answers na gi-mention ni Shane og ni Prince Edward?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, sige. So proceed ta sa next example. So example number 11, a large residence consumes 1,155 kilowatt hours of electrical energy over a billing period. Determine the total charge for the billing period based on the rate schedule provided in table 17.2. So sa 17.2 nga table, natay service charge and energy charge. So sa service charge, natay fix nga non-demand charge of $5.16. And sa energy charge, natay tulo ka components. So first, naa siya first 1,000 kilowatt hour of billing period at a rate of $0.117 per kilowatt hours. Sunod, natay next 2,000 kilowatt hours of billing period at a rate of $0.109 per kilowatt hour. And lastly, the additional kilowatt hour of billing period of at a rate of $0.102 per kilowatt hour. So the given sa problem is energy consumption of 1,155 kilowatt hours. So kailangan na to is ang total charge. So to compute the total charge, ang kailangan na to is service charge plus energy charge. So karon, fix ang service charge at $5.16. Next, ang energy charge nato, kuhaon na to ang first 1,000 kilowatt hour sa billing period. So since 1,155 ang atong given, so kuhaon na to ang 1,000 ani niya para i-multiply sa 0.117 na rate. Plus, nanasa na sunod nga part nga next 2,000 kilowatt hour of billing period. So, kuhaon na sa nato ang next 2,000 sa billing ay sa kilowatt hour consumption, but then pila ba'y nabilin sa atong energy consumption at after nato gikuhaan og 1,000 ni siya. Again, pilay nabilin sa atong energy consumption after gikuhaan nato siya 1,000. Yes, abirin mo ni.
155 kilowatt hours, sir.
Okay, thank you. So since gikuhaan man siya og 100 ay 1,000 kaganina, so ang nabilin is 155 kilowatt hours. So mo na lang ang atong i-input diri sa next 2,000 kilowatt hours. So i-multiply din siya sa iyang rate nga 0.109 kilowatt per kilowatt hours. So i-multiply lang na tanan, then i-add up din ang tulo, then nandun kay total charge of $139.06. Nasabtan ba ni nato ang process? Yes, Juby.
Sir, gawin sa lagi to, sir? Ang 155, sir?
Balik ko ha. So, 'di ba, pag abot diri sa energy charge, kuhaon na to ang first 1,000 sa consumption na to. So meaning, ang kaning 1,155 na given, kuhaon na to ang 1,000 ana. So mo nang gi-multiply siya sa 0.117 na rate. Tapos, ang nabilin anang 1,000 is 155 naman lang. Then, mo itong i-apply sa next 2,000 kilowatt hours. So, i-multiply siya sa 0.109 nga rate. So, i-add
Okay,
up.
okay, sir. Kanang next question, sir. Unsay purpose anang 0.102? Kanang additional kWh po, sir.
Kung napakay sobra, let's say, gamito na to ni next example na to. So, wait lang ha. Pasangin ko na akong example. So, what if guys, ang atong konsumo for the residential building is 3,500 kilowatt hours? How much should be the total charge for the residential building? So, use the same table for your rates. Yes, Jason.
391.16, sir.
Okay, 391.16. Sige, how about ang uban?
Unsa lagi to, sir?
Wala may kadamag sa question.
If ang given sa residential unit nga consumption is 3,500 kilowatt hours, pila na ang total charge sa residential building? Gamita lang yapon ning table 17.2 for your reference sa rates. Nakuha ba na to?
So same flow lang siya, sir, no? I-change
Yeah.
lang ang ano. Okay, sir.
I-change lang nako ang Q. Pataas mo kamot ha, mahuman mo answer. Ay, kinsa to? Ikaw, Juby, unsa imo?
Ano, sir? 394.76, sir?
Medyo ni sobra gid ka gamay, Juby ay.
3,500 to sir.
Oo, 3,500 kilowatt hours. Sige daw, unsa imo, Joey?
391.16, sir.
Okay, duha na. Ikaw, German. I mean her. Lagi, ikaw lagi German.
$394.66, sir.
Hindi, sobra pa dyan kamay. Ikaw, Shane, unsa imo?
Wait, sir, ay na-erase.
Sige, unahan sa ako ni si Ren Villanueva. Unsa imo, Ren? Ren? Gisubra pa gid ka, Ren. Ikaw daw, Monique, unsa imo?
391.16, sir.
Okay, tulo na sila pareho. Duha na po itong 394. Ikaw, Joby Axin. Kailing.
$391.16, sir.
Okay, upat na. Ikaw, Kim Harold Ibanez, unsa imo? Lima na sila.
391.16, sir.
Okay, so I guess majority nakakuha sa 391.16, which is the correct answer. So, katong nakakuha sa 391.16, palihog na kong explain be. Kinsa man to nakakuha gani ha?
Sir.
Sige, ikaw daw, Kirby. Explain daw, anong nakakuha tag 391.16.
So since nanay given na 5.16 na service charge, then since ang given na kuan kay pila to 3.5 ang rate ng luto. So minusan og 1,000 ang then ang 1,000 is multiply to 0.117. Since ang nabilin is 2.5, ang 2,000 nadtong sa 2.5 kuan na sa dadto then i-multiply sa 0.109. So, leaving us 500 na lang. So, since is additional kilowatt hour of billing period is, ang charge is $102 per kilowatt hour. So, i-multiply to 500. So, mo to, ang 516 plus 1,000 times 0.117 is equals to 117. 117 bali. So, plus 2,000 times 0.109 equals 218 siya. Then, ang 500 times 0.102 kay 81. I-add na lang din, summation is 391.16.
Okay. Thank you sa wonderful nga explanation, Kirby. So, nakuha ba to ninyo tong explanation ni Kirby, guys?
Yes, sir.
Yes, sir.
Yes, sir.
So, nasabtan na ba nato ni siya nga example?
Yes, sir.
Yes, sir.
Sige, sa proceed ta. So, next topic is the power demand charge. Commercial and industrial consumers and some all-electric residential users are assessed an additional charge based on the highest rate that energy is consumed. Maximum demand is the user's highest rate at which energy is consumed in kilowatts over a small time interval, which is usually in 15 minutes, but sometimes 30 or 60 minutes. That is measured by the electric meter during a billing period. A demand charge is the billing fee related to maximum demand. Depending on the billing rate, a high demand charge may remain at that rate for 12 months, even though the demand for succeeding months is significantly lower. For example, a small manufacturing plant that typically consumes power at a demand rate of 400 kilowatts during the day and 200 kilowatts at night. The demand charge would be based on maximum demand, which is in this case 400 kilowatts. Now, assume that because of an irregularity in plant operation, demand for power increases to 1,200 kilowatts over a 15-minute period on one day during the billing period, and the demand for succeeding periods returns to 400 kilowatts. The demand charge would now be based on 1,200 kilowatts. On some billing rate schedules, the demand charge will remain at that rate for 12 months, even though this increase in demand occurred only once for a 15-minute period. So makita na to later kung unsa di kasakit kung matunungan ka ng dako nga demand. So example 12, a small manufacturing plant on a single three-phase service consumes 104 kilowatt hours of electrical energy over a monthly billing period. The peak demand is measured at 400 kilowatts during the day and 200 kilowatts at night. Determine the total monthly charge based on the rate schedule provided in table 17.3. So, first of all, gusto ko makabalo kung unsa day ang service connection nga gi-connect aning manufacturing plant nato. Is it single phase ba siya or three phase? Sige daw, Joey.
3-phase, sir.
Okay, thank you. So, ang three-phase ang atong connection for the manufacturing plant. So, ang basis nato for the service charge is the three-phase rate of $10.36. So karon the energy consumption given is 104,000 kilowatt hours. So, ang first nato buhaton ani is similar ni siya sa katong example 11. So, kung na to ang iyang first 1,000 kilowatt hours, multiply sa iyang specific rate nga 0.0976 per kilowatt hours. Then next, 2,000 dayon, kung ano po na to ang 2,000 niya, times sa iyang rate nga 0.0885. Then, sa next na po, next 5,000 kilowatt hours, multiplied by the rate of 0.0821. And next is the next 10,000 kilowatt hours. Then multiply to the rate of 0.0712 dollars per kilowatt hour. And lastly, the additional kilowatt hour of month multiplied by the rate of 0.0657 per kilowatt hours. So, if gawandar mo, nganong 86,000 ang atong nabutang remaining, it's because ang atong total nga gikuhaan nga kilowatt hours from this value 104,000 is naatay 10,000, 5,000, 2,000, and 1,000. So i-add up na nimo ng upat ka values mo equivalent na siya sa 18,000 kilowatt hours. So kanang 18,000 kilowatt hours is isubtract nato sa 104,000 kilowatt hours. That is why ang remaining nato is 86,000 na lang. So, i-add up tong 5 ka-component sa energy charge. So, nanakay subtotal of 7,047.30. Nakuha ba ito na to, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So, next part is the demand charge. So, ang maximum demand nga recorded is 400 kilowatt. Kaya siya may pinakadako nga demand sa plant operation. So, sa demand charge nato, natay first 25 kilowatts of month multiplied by 8.85 per kilowatt na rate. Next is the next 475 kilowatt of month multiplied na po sa atong sunod na rate, mga 7.95. Then next 1,000 kilowatt of month multiplied by $7.5 per kilowatt. And lastly, the additional kilowatt of month multiplied by $7.2 per kilowatt. So since 400 man atong demand charge, so kuhaon na to ang first 25 niya multiplied to 8.85 per kilowatts. Then next 475 kilowatts, pero since gikuhaan naman na to ang 400 og 25, so nabilin 375 na lang. Paspas kay ko, sorry.
Sir, asa lagi ito nakuha ang 400, sir?
Ang 400 is the maximum demand nga na-record sa plant operation.
Nana to siya sa, sir, no? Sa
Yan,
question
siya
na,
sa
sir. Oh, sige.
question. Tara,
Sige,
dire.
thank you, sir. Nara di ay. Sige, sir.
So, para ma-compute na to ang demand charge, kuha na to ang first 25 niya. So, ang 25 kilowatts ana, i-multiply na to sa iyang rate sa $8.85 per kilowatt. The next, kuha na po na to ang next 475 kilowatts. Pero, ang 400 kilowatts na to is gikuhaan naman na to 25. Ang nabilin na lang na to is 375 kilowatts. So, ang remaining value na lang ang atong ibutang niya. So, 375 kilowatts times $7.95 per kilowatt. So, kuha na nimo ang kada demand charge. So, i-add up lang ng duha na nakay total or subtotal demand charge of 3,202.50. So, nakuha na nimo ang service charge, nakuha na nimo energy charge, and nakuha na nimo demand charge. So, i-add up lang ng tulo na nakay total monthly charge of $10,260.16. So, nakuha ba ito na to?
Yes, sir.
Dakuha kaya na, sir.
Kuhaan pa na, normal pa na niya nga operation. Unsa na nakag mag-abnormal ang operation. In is just lovely. Okay na to. Okay na lovely. Kaya nang nakakatch up na ka.
Excuse me, sir. Pwede maki-SS atong una, sir? I-screenshot lang na ako, sir.
Kane?
Yes, sir. Okay,
What
thank you, sir.
strongest lovely. Sige, so dire na ta sa case sa example 13. So much like in example number 12, a small manufacturing plant on a single three-phase service consumes 126,000 kilowatt hours of electrical energy over a monthly billing period. Peak demand is typically measured at 400 kilowatts during the day and 200 kilowatts at night. However, because of an abnormality in plant operation, demand for power increases to 1,200 kilowatts over a 15-minute period on one day during the month. Determine the total monthly charge based on the rate schedule provided in Table 17.3. So, First of all, atong service charge is since three-phase man ni siya, so balik ta sa 10.36 nga rate. So karon, kinsay pwede mo explain sa energy charge ug yun sa ni siya pagkuha? Kinsay willing?
Go, guys.
May plus point, sir.
Oh, pa-explain ko sa inyo kung kasabot ba mo aning energy charge. Dili ka, Joby. Abi na kung ikaw.
Mo yun. Ayaw, sir. Saba kay diri.
Saba lagi dayon.
Nalagi, sir. Saba kay sigta ng
Sige, ikaw
Korean
na lang, Joby.
drama. Naman sila ni Jason, sir, oh.
Si Kirby, sir. May Jason.
Ala, oy. Wala dayon. Di na sila ganag basa dayon. Ala, ha?
Ako lang, sir.
Na-shine
Anawag
na
ko
may
ka na
sir.
pa nagtubag.
Si Lovely na lang, sir.
May pa, wapo ka dun sa tingog ni Lovely ba?
Nice ang tingin ni Lovely, sir.
Ni ay? Makahipnotize lugar.
Lovely sa yung voice.
Ano, siya ang type nga boses bitaw, sir. Whenever mag-ML ka, mag-simp dahil ng mga laki, sir. Ano na siya.
Oy, boys. Tinood ba na, boys? Kasi mga comments ninyo, mga boys.
Si Kirby.
Kaya,
Tinood yun, sir. Makasing din ang tingin.
Sige, kanina lang siguro si Joyce Mariales.
Ako
Kung nasa
sir.
dira. Joyce, nakadira. Nawala ako. Lahi din nawala. Ako sa laing balay. Uy, uli na uy. So, joke lang. Ay, naku. Huwag yung magbasa sa inyo. Maulaw mo. Sige, si Kwan na lang eh.
Okay,
Sige.
rata na, sir. Face to face, sir. Pressure kayo ni sir.
Lesson yun siya.
Basta
Kwan yun. May si Eliza o Claret. Yeah, kung maka-explain ka ng energy charge, why not? Yun sa pag-solve. Pareha naman gyapon ni sa Kwan ay katong previous nga examples.
Si Lovely lagi, sir.
Basa lang yun, sir.
Hindi sila magbasa. Yeah. Yun sa man siya pag solving energy charge. Wala man na. Na naman liya tanan good.
Lagi, sir. Ako na lang, sir.
Amen kay Jason, sir.
Give chance to others man daw.
Bitaw, nga naman dapat.
Oo. May manubag po sa kong ipandawag. Kinsa may akong kuanon diri ha. Ikaw na lang, Jomar. Nakadira.
Go, Jomar.
Ingko kasabot ka sa previous na slides.
Ayang kani mga sa energy charge, sir. Kung gin sa pag-come up ng 126,000 kilowatts hour.
Given na ng 126,000. Yan na, Jomar. Di sila. Sige, magbat na lang kong laing example. Ako lang ng tiwason nga example, but later. Sige, Kirby. Sige na, Kirby.
So, morning. Okay, sir. Since three-phase connection man to, hindi ko niya. So, naanatay daan na $10.36 you given na. So, since energy charge since natong kuan kay given na ang 126,000 kilowatt hour, i-multiply na sa din nato sa rate na po dayon for each kaning cut off. So first 1,000, ang first 1,000 is i-multiply to pila ni? $0.0976, which gives us $97.60. Then next, may ang kaning ang nabilin sa 126,000 minus 1,000, minusan na sa nato og 2,000 kilowatt hours. Then ang 2,000 kilowatt hours i-multiply na po nato to 0.0885 kilowatt hour dollars per kilowatt hour. So ang result is $177. So next na sa dayon ang katong nabilin sa kuan sa 126 nga giminusan og 1,000 tas giminusan pa gyud og 2,000, kuhaan na sa natog 5,000. Then ang katong 5,000 kilowatt hours i-multiply na sa dayon to $0.0821 per kilowatt hour, which gives us $410.50. Then ang katong nabili na sa dayon sa 126,000 nga giminusan og 1,000, nga giminusan pa gyud og 2,000 tas giminusan pa gyud og 5,000, minusan na sa 10,000 kilowatt hours. Then ang kaning kilowatt at 10,000 kilowatt hours i-multiply sa $0.0712 per kilowatt hour, which gives us a result of $712. Then ang katong remaining
Si Kirby.
56 112 hours of 8 kilowatt hours. Okay, naputol. So since naandiri ang kuan sa table nga additional kilowatt hour of month, kay ang rate niya is 0.0 $657. $177 plus 410.5 plus $712 plus 7,095.60. Then ang energy charge dayon is 8,492.7. That's all, sir.
Okay. Thank you sa wonderful nga explanation, Kirby. Gidugangan gid niya para masabtan gid sa tanan. So nga to lang. So nasabtan ba
Thank you,
ninyo ang giingon ni Kirby?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Like,
Yes, sir.
honestly,
Yes, sir.
Yes,
like wholeheartedly,
Yes, sir.
honestly, good.
Yes, sir.
Yes,
Sir,
sir.
na kay question, sir.
Isa to, Joby. Yes.
Kana bang ag-solve ang mga taga-sipal ko ana, sir?
Grabe ka, Kuan. Kuan na siya, makita na siya sa electric bill na siya. In charge ng mga calculation sa mga electric bills, anak Joby, sa Sipalco. Though, wala
Pwede
pa
na may
ko
magtrabaho,
makitaan na
sir.
sa mga...
Ga-recruit sila, sir.
Sir, magtrabaho na lang,
Trabaho na lang
sir.
yan.
Kabalo naman.
Pagpan.
Ano na lang, di na lang may mag... Okay na, sir. Si Kirby, among ano, sir, among head manager.
Kung dili may kapasar board exemption, magtrabaho na municipal ko.
Pero bito, kaning example na to sa power demand charge is mostly gakakita ni siya sa mga industrial na mga clients ni. Dili na to ni sila makita sa residential na billing. Kung pansin ninyo, wala tayong ani sa residential, di ba? Katurang simple nga energy charge, moro to atuan dito.
Yes, sir. Ay, ako kayong bill, sir. Ginawa.
Yeah. So, before ko
Sangkag.
proceed pa, kanang basing ka wonder mo ba kanang sige kog panawag sa inyo ha kanang para mag-answer. Kana akong
Para
tawag-tawag nga
makamata
sa
mi,
inyo
sir.
ka is well, aside ana graded nga oral recitation ni siya. Basig dili mo aware ba or nakalimot mo sa orientation. Wala good participate ba? May na lang namoy points.
Ulangan man, mi, sir.
Oh, bahala bro ang answer. Ang importante man gud sa ako is mo participate ta tanan ba. Dili bitaw kay kabrang mga snob kaayo nga di manubag.
Yes,
Ang
sir.
importante
Wata kabalo ng dula naman din.
Ay, trust issues, sir.
makasabot mo.
Natulog na sila sir.
Hala, sorry ha.
Oh, na. Bitaw tinuod ba na nga possibilities? Di man gud ta kaingon ba kay tungod kay online ta ba? Di na
Yes, sir.
kaingon nga naadira present pero in
Sir,
reality
daw binalibang,
kasi nang
sir.
Sa mukha.
ano dayon
Makasold pa
Sir, hindi ka banding, sir. Magdala, may calculator sa CR lugar,
Wala ta, nagtile
sir.
sa
Lain na uy.
CR, sir.
nakadala mo kay cellphone sa CR.
Ay nga na din na, sir.
Oh.
Bala na, sir, na ay flash.
Katong
Flash
mga
nga
guba
Ano
to.
ko
o
ba yun?
pwede ra mo nga mag-chat na lang. I-chat na lang ninyo katong mga guba og mic or katong putol-putol og signal para at least makita na ko ba nga participate pud mo. Okay? Kadungog klaro ba to?
Yes, sir. Klaro na, sir.
Yes,
Murag
sir.
kamura gid nga section ako na explainan about anak ba. Kuban kay hilom-hilom ra ba to speakers.
Yes, sir.
Gusto namin magtrabaho, sir, kay
Char, lahir gid si Joby oy. Mura man
kailangan
siya
may
Yes, sir.
money.
Very industrious, sir.
Money.
Yan ang sir.
wala pas-pas daw ako ma-explain. Patay. Patay gid ko ani kalabli ba. Bitaw guys,
Si
kung
Lovely dapat, sir, oh.
Sir, pa-send me sa imong power.
mag-send ko after sa na to, klase. Pati po to sa assignment later. So,
Thank you,
kung
sir.
in times lang nga, pas po ko sa akong discussion, badlo nga po ko ninyo, kay nagid ko bad habit anak yun. O sa hindi
Sige,
makontrol,
sir.
saan bito na ako.
Ayaw lang
Lagi-
may minus points, sir, habasin.
Ay, wala minus points man na. Kung man na, tinabanga lang good-tagod. Naapog ko recorded na video pod. Nag-record gid ko para sa inyo ha.
Sana all special.
Sana, love evening mo, sir, ba?
Thank you, sir.
Siguro, char. Bito kay. Ako lang kay ang makatabang lang pud ba. Kamo bito. Lisod baya karon nga panahon na. So, sige, proceed ta. So, next is the demand charge. So, since ang abnormality nag-occur, so ang power demand nga na-record karon is 1,200 kilowatts na siya. So karon, ang bato na to ani is kaon na to ang demand charge based on the 1,200 kilowatts. So kaon na to ang first 25 kilowatts. So times sa iyahang rate of $8.85 per kilowatts. The next, kaon na po na to ang next 475 kilowatts niya, then multiplied by the rate of $7.95 per kilowatts. And next, kaon na po na to ang next 1,000 niya, pero after gideduct na to ning 1,2 sa 25 of 475, that's roughly mga 500 kilowatts. So pila na lay na bilin sa ato ang kilowatts. So 1,200 minus 500 is equal to 700, which is kanang 700 nga nabilin i-multiply nato sa $7.5 per kilowatt na rate. So i-multiply lang na silang tulo, then i-add up, so na kay demand charge subtotal of $9,247.50. So after makuha nimo ang service charge, energy charge, and demand charge, i-add up na silang tulo, then makakuha na kag value of $17,750.56. Nakuha ba to na to?
Yes, sir.
Yes,
Yes,
sir.
sir.
Kanang 8,000, sir, kay nasa past slide, sir, di ba? Imong
Yeah.
i-add lang to. Sige, sige.
So nakita ninyo no, nga layo kay difference tong 400 kilowatts nga demand versus sa kaning nay abnormality. No, halos 7,000.
Yes, sir.
Patay tayo
Sir,
dyan
may
sa manit.
doon na lang nato ang kuryente, sir. Sa mas mahal pa man na sa salary sa civil tingali.
Tinuod yun siya. Pero ayos sa dakot na. Uy, luoy sad ka sa laing consumers. So, yes, lovely. How about sa water? Ano sa'yo nasa water, lovely?
Bill daw siguro, sir.
Kay ang billing sayop lagi per me. Wala mi gagamit tapos pero na ay bayad. Dako ang bayad, lovely. Like unsa ka dako in terms of amount? $700. Dako gid siya ay. Minimum ra gayeng ako adere. Basig na ay leaking sa inyohang tubo ana, lovely. Or basig daot ang inyong mga faucets so galik ang tubig. Or basig sa inyong bowl nga gasigig andar then di siya gaka-off maski na human na dugay ra ka nag-flush. Ana bitaw? Basi na leaking ba? Pa-check daw na ninyo. O aside ana, basin po na galik gikan sa meter po sa inyong tubig. So i-check lang na nga mga possibilities. Pero sa manggod maski nag-ingon ta nga di ta gagamit pero kung naan ng mga leaking manggod gaka-record na siya sa meter. So mo na siyang gadako ang bill. Okay ba, lovely? Nakuha ba to?
Kasi naiga jumper, sir.
Ha, naon sa to, Christian?
Jumper, sir. Jumper.
Oh, posible po na. Okay. So, as shown in the previous examples, a one-time peak in maximum demand caused the manufacturer an extra demand charge of $7,490.40 per month. When billing rate schedules for maximum demand is carried for 12 months, this equates to $89,884.80 annual increase. Patay ka dyan kang presidente. Nasukan din ka niya. Ano na yung animan eh? Mahal ka ayo ang kuan. Kurente. So this additional charge appears excessive but is rationalized because utility companies are legally charged with the task of providing power regardless of demand. So a utility company must have the extra generating capacity to produce electricity during periods of peak demand, like during the afternoon of the hottest day of the year, even if this extra capacity is used only a few hours per year. Simply, the demand charge is needed for the utility to recover its investment in extra generating, transmission, and distribution capacity that is required to meet infrequent peak electrical demands. It is more profitable for the utility company and thus more economical for the consumer to keep demand uniform. When demand is uniform, the utility more effectively utilizes its generating, transmission, and distribution system. The demand penalty imposed by the utility to keep demand uniform encourages the consumer to level off demand peaks. So leveling demand is achieved in many ways. Demand limiting is accomplished by disconnecting loads that are not needed during periods of high demand. Load shedding is a method by which non-essential equipment and appliances are deliberately switched off to maintain a uniform load, thus limit demand. Load shifting moves non-essential loads to periods of load demand. In small installations, load shedding and shifting may be accomplished manually by scheduling the startup and shutdown of a piece of equipment during certain periods of the day when known peaks occur. In sophisticated commercial and industrial installations, load shedding and shifting may be accomplished with an energy management system that monitors demand and sheds and shifts loads in a prioritized manner. So considering nga naatay load profile sa isa ka retail store kani siya, so peak use occurs as the store opens for operation. So mag-open siya at around 9 a.m. So nadira ang peak daw, peak hours. So some HVAC and domestic hot water consumption could be shifted to before 9 a.m. Peak usage could be dropped to about 5 kilowatts. So kanina sila, ang HVAC and water heating is nakatunong sa 9 a.m. So instead na i-on nato na sila during the opening of the store, what if ato na silang i-move dere sa 8 a.m. So kung i-move nato na siya sa 8 a.m., ang atong demand pagka 9 a.m. onwards is maminus na siya. Nasabtan ba ninyo? So murag gibalhin lang nato ang usage aning HVAC o kaning water heating para dili dako ang atong demand nga makuha. Nasabtan ba?
Yes, sir.
Okay, so energy storage and alternate sources of energy can also be used to reduce demand peaks, a technique called peak shaving. So first example, in an ice storage system, ice is made by a building's air conditioning system at night when demands are low. The stored ice is then melted to chill water for cooling the building when air conditioning demand peaks the afternoon. Ice storage has the added benefit of requiring reduced air conditioning capacity. A cogeneration system that produces electricity from waste process heating or by consuming fossil fuels can be used to limit demand. Next example is load shifting maximizes the solar power usage as it is being generated. Simply put, use the solar power immediately instead of selling or storing it in the battery. So, for example, og naa kay washing machine or dishwasher nga nay delay feature, pwede nimo i-on ang imuhang dishwasher from 11 to 12 or ang washing machine into 12 to 1. Your power usage gets taken care of directly from the solar and the power company never sees the increase in your load. So, ingani na siya may tabo. So, observe ninyo ning graph. Kung wala may solar, guys, kani ang inyong overall na kwaon sa utility. So, karon naman kay solar, then ga-under ka during the peak hours. So, ang solar nimo, siya ga-supply og power for that dishwasher or washing machine. So, ang kakakuha na lang nato nga demand from the utility is ingani na lang kagamaya. So, na-cut off ang kuan excess power. Kaya naman si solar nag-provide. Nakuha ba nato?
Yes, sir.
Yes,
Nakuha.
sir. Kanang naki-question, sir. Kanang unsa nang mag-short ang electricity, sir, dili na maano ang demand sa electricity sa mga appliances, sir? Na din
What do
kanang short nga term, kanang ma-short bitaw, unsa ba?
What do you mean sa short? Kinagan mo, kuan man good. Akong gawanahonan nga short, ka ng short circuit.
Murag ingon ha, sir, like
Lahi
kanang wait
ng
lang,
short
mga
circuit.
tana ko kay mama.
Wala ton sa nato siya nga mahuman og pangutana sa iyang mama po.
Ay, short circuit dahil, sir.
Lahi na
Lahi
siyang
sad
short.
nga.
Yeah, ang short circuit kasi
Okay.
is kuan na siya, similar sa fault. So, example, katong gi-present na ko last week, kung gihawiran nimo tong extension cord ninyo, then nakita ninyo ang copper ato, kamo ang short circuit ato. Kay instead na niadto siya sa inyong appliance nga nakapansak sa extension cord, sa imo na ginoon na padulong ang kuryente. Yeah, tinuod. Wala siya.
Unsa sad na ano, sir, kanang mubuto ang generator, sir? Kay tungod kanang dako kayong demand, example sa barangay, dako ang demand bitaw gikuha sa electricity, sir. Maano na siya diri, sir, sa demand limiting and load shedding, sir?
Oo, diri ni nato siya magamit. So instead na maggamit kag daghan na appliances on that certain time, why not ibalhin nato ang usage sa uban? Ing ani man pod among usually gina-recommend sa among mga clients nga ga-solar. So think man gud sila nga nganong dako man mig bill nga naman minta mi solar. Kay di ba, pag nakay solar mo gamay imong bill. Karon, ang reklamo sa uban, dako man gyapon mig bill. Okay, ang nakapait di ay sa ila. Ang ilahang appliances is dako ilang gamit sa night time. So amo silang ginasuggest nga why not gamiton ni nila sa daytime para si solar na mag-provide sa electricity para ana ng mga appliances instead na sa grid. So nga na siya. Similar gyapon ana ba gi-move nimo ang time kung kanasaan nimo sila gamiton.
Pero
Nakuha ba to na?
pwede po nimo siya mo ano, sir. Like, ma-store nimong ano, power. Then magamit din nimo sa night time.
Kung na kay battery, okay ra. Ang cases man gud nga gareklamo ging ana kay katong mga walay battery.
Oh, yeah. Okay.
Oh. So man ang kung pwede, ang imong usage sa gabi ibalhin na lang sa daytime para si solar ray mo provide og power ato. So naka-reduce ra ka sa imong electricity consumption, di ba?
Yes, sir.
Okay, so kuha ba nato ni? Okay na ta, guys?
Kuha ra,
Yes, sir.
sir.
Kuwara, sir.
Okay, so abi ng last. Second to the last, time of use rates. The time of use rate rewards the user for reducing power consumption during periods when electrical demand is highest and a lower rate for the remainder of the year. In most climates, the peak period occurs during the midday and early evening hours during the cooling season because the weather is hottest and power consumption is greatest. So for example, sa kaning table, at summer peak on 1 p.m. to 7 p.m. at June 1 to September 30, kung napansin ninyo, taas ang presyo sa electricity. Maabot og mga 23, 21 cents per kilowatt hours. Kung summer off peaks, like from 7:01 to 12:59, late ba kayo? So anyways, so pag kuan, naa ka sa 7:01 p.m. to 12:59 p.m. at June 1 to September 30, mubarato pod ang atong rate sa kuryente pod nato. And sa other times, from October 1 to May 31, mas barato ang atong rate sa kuryente. So kani ngani na mga rates is I think nakakita ra ni siya sa gawas. I never heard nga gagamit taan ni nga time of use rates. So sige, proceed lang ko sa last part. So additional charges. Additional surcharges for service and fuel adjustment may also be assessed. The service or billing charge covers the cost of metering and bill collecting activities such as meter reading and preparing and mailing billing statements. This charge is assessed even if no electricity was consumed. The fuel adjustment charge reflects periodic changes in the cost of purchasing, delivering, handling, and storing raw fuel such as coal and natural gas that is used to produce electricity. It is typically applied to each kilowatt consumed. So, that ends our topic for tonight. So, hatag na akong assignment. So, ang assignment na to guys, kindly answer problem number 17.37 to 17.39 sa atong reference book. So, nana ni siya sa group chat kung in case wa mo naka-download. So, in case wa po mo copy, ay sorry, wait lang. So, in case wa po mo copy na ako'y ingani po na file. Ayay, naguba. Wait lang guys ha, naguba akong file. Walang hiya, giguba gid niya da. Ano na lang guys, ako rang isend ang ano. Ako rang isend ang file for the assignment kay nadaot akong file. Abot taon sa ni.
Okay, sir.
Okay po, sir.
Sige, so next week, ang deadline sa assignment na to by the way ha is before sa class schedule. So before 6 p.m. dapat makasubmit na tanan sa assignment. Tapos next week pod mag-quiz na pud ta. Mag-quiz ta, ang topic na to is kaning whole module 1, katong discussion from last week and karong gabi. And also Oh, yes, Shing.
Excuse me, sir. Unsay type sa quiz, sir? Sa UST may mag-quiz, sir. Ay, sa Prism, ay sa USTEP may mag-quiz, sir.
Ako rang ihatag ang question sa group chat. Then,
Okay.
isubmit lang din sa USTEP.
Within sa 3 hours class na ni mo, sir?
Dili. Actually, akong
Okay.
quiz kay short ra, so dili ra ta mabot og 3 hours ana ka quiz.
Okay, sir. Thank you.
Yes, Bell. Asang assignment? Kaning assignment karon or katong seat work? Kuan, next week, Bell. Sa ba next week? March 2. Before 6 p.m. ha? Yes, Jason, sa imo pod.
About sa kwanse ba? Katong 17.39.
Yes.
Ang table bitaw, sir. Show your solution, yun sir.
Pwede ra sa table na siguro ni ibutang ang solution.
Okay, sir. Thank you, sir.
So, any questions pa ba?
None so far po, I guess.
Sana all none so far na. Jason.
About aming concern, 17.38, sir ba? Kanang, di ba, ang gipangita is niya niyang Q or energy? Mag-state pa siya concern like kilowatt hour per year, something like that, per month. Ito, sir.
Sabi, na to sa 17.38. Asa dari nga number? Determine the energy consumed for 1 year. Imo ni siyang isolve ginang 1 year nga energy consumption.
So, dapat ang final answer, sir, kay naka kilowatt hour per year.
Yeah, kilowatt hour per year ni siya.
Okay, sir. Thank you.
Okay, unsa pa yung mga bongacious na questions? Appeal man na siya sa abnormality. Pero sa katong nga case sa atong example is dili brand out ang abnormality ato. More on sa operation sa planta gidto siya. So naay something wrong sa planta mo to nakagamit ka og ingato kadako nga power demand. Yes, Jason.
About the assignment, sir, pwede na siya encoded or handwritten, good siya, sir.
Hindi ninyo.
Okay, sir. Thank you.
Kung inyong pahimos lang tong Word na file ang gihatag, okay po. Total na dito tanang questions na. May kaso basta kay ang importante gid sa ako makapasa mo on time. Kay dili ko gustuhan na mag deductions kay kapoy kaayo. So please lang pasa lang gid tag on time.
Basta magud ikan ra nila i-list down ra nila answer ba name. Name ra gyapon
Ah.
output.
Mausad. Sige, sulat na lang nato eh.
Sir, di
Sulat
na
na
lang
lang
magdeduct, sir, para may problema.
Eh, unfair kaysa akong aside.
Di man, sir, di
Bitaw,
na kailangan magdeduct. Di ba?
bitaw kay submit lang gid ta sa oras lang gid sa saktong oras. Ayaw gid to awat dito sa pikas nga ambot unsa nga asa daw i-submit ang assignment. Klaro kay sa instruction wa nagbasa eh. Ambot na lang gid. Sayo pag sa buntag na chat, kalas kay sa brain cells ug explain.
Sorry, sir. Charot.
Dili man sa kanang kuan nakuan lang ko ba kana ha? Naman gud sa instructions. Marami itong nagsayo kag mata kay nagluto ka kay Pumunta siya kung life story ka
At
na
least,
adlaw.
sir, na nag-message early morning, sir.
Lagi. Lang. Nag-life story lang ko for the day. Nasayo nagmata kay nagluto. So, sige. So, unsa pa may mga pangutana na to?
Sir, kanang what if dili mi maka-attend karon nga meeting, example, karon nga meeting since nag-ingon, kami ang last nga to section, sir, na imong tudloan, sir.
Yeah, kamo.
So what if, sir, di mi maka-attend for some reasons, like na aming meetings or na something personal gathering sa family or emergency, unsaon man na namo, sir, pag make up class, sir, or lang ka sa attendance, i-consider nimo, sir, or dili?
Ang sa attendance, pwede naman ako na ma-excuse as long as na nang head. Karon kung wa ka na nang head sa ako, maabsinan gid ka, zero pa jud ka. Mao lang na.
Okay. Sige,
Ang
sir. Thank you.
ako as much as possible kung maka-absent magali mo, pananghid mo daan gyud. Dili ko gusto nga makadungog nga nagkuan ka na nabitay daghang pangutana ba nga kuan kay naka-absent lagi. So please lang kung maka-absent magali pananghid lang gid mo daan para di ta ngita ba asa di siya. Wala man siya diri karon.
Sige, sir. Thank you.
So, kuan na lang yun, be. Unsa man ako magkuan ha? Mag-example, na-discussan na ako ang previous na sections, tapos kamo, wala mo naka-attend. Marag video recording, lagi ta makabawi anak ba?
Nabalaw ko, sir, kay nag-seen raman jud ka sa akong message, sir.
Ha? Nag-message ka na ko?
Wala ay na, sir. Okay na.
Ala.
Salamat na sa lahat, sir. Nagdali na. Gipadali na lang gid ako. Okay na lang. Okay na human na sa ating ko. Ayaw na, sir. Di na ko.
Load na siya, sir.
Wala ko ka-reply kay dili ko ganahan mag-chat o kanang ing-ani nga oras kay basin, makasukan ta sa watong bae. Maldita na ba kay ito?
Ay,
ala.
sige.
Yeah, na, kanang iwas issues lang ba? Lisod na.
Sige, noted, sir. To na lang ko
Dili kay kan man gud unta mo reply mo unta ko buntag na busy ko ba? Yes, Joyce, unsa imo?
Sir, ask lang ko about bitong brownout, sir, blackout. Kanang necessary, kanang ibto ni mo tong nasa mga outlet na nga saksak. Kaingon sila kay, if mag-brownout, need daw ni mo tong ibton para wala additional charges. You know that, sir?
Iya, kay pag kuan man gud, pag naang imo mga appliances nakapansak, so gapasulod kag kuryente diretso. So posible nga dako nga kuryente mo sulod sa inyo ha, so paspas dako. paspas ang tuyok sa inyong meter. So meaning dako ang increase sa inyong consumption. Mo nang rason nga mo taas ang bill.
Thank you, sir.
Karon palagi ko kadungog sa tingog ni Joyce after tawag no ko ganina. Unsa man ni oy? Sige, so napabatay questions? Oh. Napabatay questions so far? Or wala na?
Wala na, sir, kay
Or wala na, no? Sige lang. So, I think na na-announce na ako, no? Mag-quiz-ta, then mag-discuss tag new topic next week. So, by the way, dahil ha, kanang kalimot lang ko. Ang section N, ang 2N14 is mo appeal o klase sa inyo next week. Dapat may mga kaila dito?
Wala po. Yes, sir.
Wala.
Oo. So, mosabay sila og quiz sa inyo ha o mag new topic. It's because natunaw man gud ilang schedule sa 25 which is a holiday. So instead na magkuan pa kog make up class, ako na lang giisa para dili na kayo kuan sa oras ba. So okay, so expect kita
Sir.
nga daghan ita next week. Yes. Yes, Miles.
Hi, sir. Sorry kayo, sir. Karon na jud ko nakasulod.
Wa man lang ka na nang hidug aha ka.
Sir, kay abi gid ako makauli ko by 6, sir. Nya, grabe gid ka busy, sir. Kay mag-host man gyud ko tomorrow sa General Assembly bitaw sa USG. Nya, grabe. Pasensya kayo, sir. Next time I will PM and regarding the time and everything, sir. Pasensya kayo, sir.
Manangin lang lagi sa sunod lagi gaka-hurt niya akong delicate heart.
Sorry kayo, sir. Yes, sir. Promise next time. Abi man gid nako, sir, makauli ko by like 6, then wala na connection sa amo ang gisat-apan bitaw, sir, pag giadtoan. Sorry kayo, sir. Next time. Thank you po.
Okay, so I think wala na tayong mga concerns and question, no? So, ako lang i-upload ang ang assignment and an presentation karong gabi. So, ang assignment is written ha, then picture dayon. Then submit as PDF. So, i-follow lang dayon ang instruction sa katong assignment. So, mo lang to. So, class dismiss na ta.
Solution na sir ba?
Copy and answer.
Okay, sir. Thank you.
Okay. Sige, so class dismiss na ta, guys.
Bye, sir.
Bye, sir. God bless you po. Thank you po.
Thank you, sir.
Thank you.